Alright guys, this video is going to cover a couple of problems out of section 3.1. It's really important that I just touch on a couple of more things out of section 3.1 very quickly. This won't be a lot, maybe 4 or 5 problems, and then we'll go into chapter 4. The reason why I am shooting this way tonight is because I think it's really good that we get through a certain amount of content and material, and this allows me that free range to put a lot of content in this video and for you to just pause and stop and move at your own pace, make sure you're understanding, replay me back if you need to, and then also focus on doing your Connect Math over the weekend for sections 4.1, 4.2, and then also if you need to do section 3.1. If you can get to section 4.3, that would be great, but I'm going to shoot 2 videos tonight, and again I found my document camera, which is really exciting for me. Of course, I'm nerdy like that, but I found my document camera, and this allows me to capture problems and UC steps just like we would be in class, and it's just going to allow me to get a lot of material in this video. All right, so with further ado, let's jump into it. So one thing that I want to, I already wrote this problem down, but I wanted to touch one more time on decimals, just to be clear if you get an inequality that has decimals in it. So notice for this one, the original problem was what was in parentheses. I multiplied by a factor of 10 because I noticed that I had tenths place, okay? If there would have been one of these terms that would have been, let's say, 0.47, then I would have multiplied by 100. You always multiply by the greatest number of decimal places after the decimal, or place values after the decimal. So I did 10 in this case, and as you can see, when I put that parentheses around this entire inequality, I will multiply by 10 to each individual term. Okay, all of these terms get multiplied by 10, and then it creates whole numbers. All right, and remember I said I like to put my variables or letters to the left, and I move my numbers to the right. So I'm going to change colors real quick. And so this 20C, notice I changed the sign. Okay, when I'm talking about one side and the other, it's basically cutting that inequality problem in half through the inequality symbol. So I'm going to add 20 here, and then I'm going to add 20C there. This is gone. Draw my line, and then we get 24C. We're combining like terms. Still have that greater than, and then don't forget the sign on the -4. Okay. Now what we're going to do is numbers move to the right, so I'm going to subtract 12. What I do to one side, do to the other. Okay, so now this becomes 24C greater than, and if you want to put a little plus, see that? Because you're always doing addition, but then you step back and look at the rule of integers, right? So I always put a plus with when I'm combining my like terms, okay, when they're stacked like this vertically. So this is a -16. Then I'm going to divide by 24 to both sides. Notice that that 24 is a positive number. It's a positive number, so that means I don't have to change the direction of my inequality. And now I have a fraction. I left my negative sign there, and these, the greatest factor that these have in common is 8. So I'm going to divide this by 8 and get a -2. Divide this by 8, and I'm going to get a 3. So there's the answer. C is greater than -2/3. I'm sorry for that slight kind of hesitation. I was checking a solution in the book and it's different, so they have a typo and this is the correct answer. The other thing that I wanted to mention is sometime I may pause or at least mute myself in the video if the background noise is too loud, with the kid running around or a machine playing. So you may hear me, it sound like it pauses, or you won't hear any sound, and then I will come back. All right, so that's the answer. Okay, now if you were putting this in set builder notation, you would do the squiggly line C such that C is greater than -2/3. And if you were doing it as a interval notation, of course, remember you want to be greater than -2/3. So what we would do is, I'm just going to do the number line and graph it real quick. So we would have, like, say 0 here. Let's say we have -1 here. -2/3. So this is -0.5, but -2/3 is basically negative 0.667. Okay, so I'm going to just basically put it a little over to the left. Let's say about right here. So we'll smidge it over this way, close to -1. And then notice that there's no line under the inequality, so it's going to be a parentheses, and we're going to face it going towards the right. Okay, so we would shade everything greater than going this way. Okay, and when you do that, then that gives you some help to see the interval notation. So it would be parentheses, -2/3, comma, to positive infinity. All right, so those are the ways that you would list those real quick. All right, let's go to the next problem. Okay, for the next problem, I'm going to just do one real quick with whole numbers. And let's see this one. -2x plus 5 greater than or equal to -x plus 5. All right, so again, whole numbers, so everything is good. Let's do letters to the left, numbers to the right. So I'm going to move this x over to this side, draw my line. This is gone. And then this becomes a -1x, but we're just going to put a -x. Okay, because remember, this is a 1 here. You would subtract, keep the sign of the bigger number, add the 5 down, greater than or equal to, and then we have a 5 here. Then I'm going to do numbers to the right. So I'm going to subtract this 5 over, move it over to the right. Remember, you have to always change the sign to move a term from one side to the other side, okay? Whether it's an equal sign or an inequality sign. So there's your -x, greater than or equal to, and this is 0. Now remember, I already see that there's a negative in front of my, as a coefficient on the x. So when I divide by -1, this is the step that I'm going to flip the inequality symbol. So x, it's not going to be greater than, it's going to change direction. We still have a 0 there. That's the solution. Okay, and the set builder, x such that x is less than or equal to 0. And then here, you're going to see that there's a line under here, right? So you want to do a bracket, and we want to be what? X is less than. So we want to face it towards the left and shade everything less than toward -infinity. So there's the graph. So for the interval notation, again, towards -infinity, remember, it's always on the left. So -infinity, comma, 0, bracket. That's the interval notation. So there's all three. There's set builder, there's interval, there's graph. Okay, so now for the next one. Okay, so let's do the next one. So as you can see, again, that last one, I believe, was x less than or equal to 0. Let's try these, okay? So there are some problems on 196 that say determine if the given number is a solution. Sorry, it's a little crooked. Is a solution to the inequality. All right, so let's look at this for a second. Okay. All right, so I'm going to zoom in a little bit. Okay, so everybody can read that. All right, so what if they gave us something like 3 minus k, open parentheses, I'm sorry, less than, then 2 open parentheses, -1 plus k. That's the problem. And basically they're trying to ask you, can a equal 4, yes or no? So I'm going to write right here, k equals 4, and you have to say yes or no. All right, so what we're going to do, of course, is we could just substitute it. Remember, another word for the equal sign is the word is. So we're saying k is 4 when you put that equal. So what we're going to do here is leave the 3 there. Everywhere that k is, substitute in a 4. Watch your signs. Got -1 plus 4. So again, I substituted in 4 for the letter k. And we're going to check if we get a true statement. You know, is the stuff over here on the left less than the information that's on the right? So this right here is -1. But remember, I told you guys I don't like subtraction sentences, or we don't like them. So we could change to a positive sentence, bump back the negative. So every time we have a minus, just change to a plus, bump back the negative. So this becomes a -1 less than. Now we'll do our parentheses. So we got 2 open parentheses, 4 minus 1 is 3, a positive 3. So is negative 1 less than positive 6? That is a true statement. I put a check on it, so therefore, yes. K equals 4, yes. This is a possible solution. Okay? So that takes care of that one. Let's do one more of those, and then I'm going to do some other statements. Okay? So again, same type of problem, so I'm not going to write the directions again. So here's another one. What if they gave us that we have 4 open parentheses p plus 7 close minus 1 greater than 2 plus p? The question is p equal to 1 a solution? P equal 1. So p is 1. Is that a possible solution? Remember that I told you that when you have inequality symbols, okay, whether that's the greater thans, the greater than or equal to, less than or equal to, remember I told you you get infinite solutions, okay, unless it's a compound inequality, then you have these boundaries or limits. But when we're shading things to the left or to the right, like we did on those last 2 problems, I'm just going to show those again. All of these are solutions. Decimal numbers and whole numbers all the way to this infinity positive, just like here, zeros included and everything over towards negative infinity. Okay, so we get a lot of solutions. So what's happening in these problems here is they're giving us one to try, and they're asking us, hey, is this a possible solution to the inequality? When you have an equal sign, you just get one solution. All right, so here we go. 4 open parentheses, we're going to plug in a 1. 2 plus, again, 1. Okay, I'll just zoom in here. So now what we have here is if I add those together, that's 8. So I have 4 times 8 minus 1 greater than 3. Okay, and then we know 8 times 4 is going to be, why did I just have a brain fog? 32 minus 1. Okay, and then this is 31. Is that greater than 3? And, oops, sorry, I cut it off. That is true. So yes, okay, this is a solution. All right, so I hope that makes sense. All right, let's move on to something else. All right, so the last thing I want to show in section 3.1, and there are some word problems, but we're not going to worry about word problems right now. So this right here talks about, I'm just going to put translating English phrases to mathematical inequalities, to math inequalities. Let's just put that. Here we go. So this was the thing where we talked about, 7 less than some number is, right? This is those kind of statements. So let's look at this one, and I'll try to write a couple out. So it says the wind speed, they're denoting it as W, exceeds, so when you hear exceeded or exceeds, 75 miles per hour. So basically, if it exceeds, it's greater than, right? So now they don't tell me the wind speed is exceeding 75 miles per hour. You see what I'm saying? If they said the wind speed is exceeding 75 miles per hour, or the wind speed is 75 miles per hour and exceeding, something along those lines, that would tell me to include the 75 and everything greater. So the answer to this one, let me switch colors, is just W greater than 75. They don't give me any information to tell me that I am equal to 75 and then also greater, but exceeding means I'm bigger. Okay, let's try this one. Okay, the length of a fish, L, so they give you the variable, was at least 10 inches. Okay, so we have this fish, the length of it, L, okay, was at least, so that means that it has a minimum. Okay, you see that? was at least, was as small, okay, as 10 inches. Could it be bigger? Yes, it could be bigger. So again, it was at least, it was this small, and therefore it's bigger than that, okay? So it's going to be a greater than or equal to 10. One more time. So the length of a fish L was, in the past, was at least, the smallest it was 10 inches, right? At some point in the past, and it can be what? Greater, because you can't shrink, of course, unless it's sick, but for the most part, we're just going to say was at least, so it was a minimum of 10 inches and then greater. So that's that one. And then let me just do one more. Let's try this one. The snowfall, move up right here. The snowfall H in Monroe County, okay, in Monroe County is between. So I hear some limitations there, 2 inches and 5 inches. So this is where we get into a compound inequality or statement, because again, I have some boundaries or limitations. So therefore, we're going to put, remember, it's between 2 inches and 5. So I know to do that. I know we're talking about snowfall H, and if it's saying it's between there, then that definitely means I want to be greater than 2 but less than 5, and then it doesn't give me any indication because it says between. Okay, I'm going to underline that. So I'm between there, I'm not 2 and I'm not 5. Okay, so again, that takes care of just a couple of those statements. Again, this is page 196. You're more than welcome to look at that. Also, you know, like I said, I don't know if these come up in the homework, but I wanted to touch on those. And then I also wanted to touch on, you know, a decimal and then checking a solution. All right. So let me pause here. Okay. So this is, I know that I said I wasn't really going to go much into 4.1, but 4.1, remember, is about graphing, or I'm sorry, the rectangular coordinate system. This is page 205. So notice that I'm just going to finish this video off with, again, the end of 3.1, 4.1, and then the next video we'll pick up from 4.2. But I just wanted to touch on word problems. So what you should have done at this point is you understand that the, you know, x-axis is always horizontal. Okay, here's an x-axis. Here is your y-axis. In the notes on Tuesday, I basically showed you, let me see if I can find a picture of it. I showed you something like this. Okay, we took some notes, and I'll go back. We looked at this, and we said, hey, you know, things here, if I'm at 0, 0, which is the origin, that's where you start always. You know, if I start here, my x is always the first coordinate, and then y is the second coordinate, right? So I started 0, 0, and if this is a positive number for x, then again, I'm going to horizontally jump to the right, positive. If this x, go back to 0, 0, is a negative, then I'm going to move to the left first. So remember, you always moved left or right first. If it's a positive number, go to the right. If it's a negative, go to the left, okay? Then from there, once, let's say I move out to the right, okay, in this case, I'm at 3. If my y value is positive, then from this position, after I've moved to the right 3, then I would go what? Up, let's say to 5. I'm just giving an example. So if y is positive, we move up, and if y is negative, then we move down. All right, so again, you always move left, right, depending on the sign of that x number, and then we go up and down depending on the sign of the y number. Right, then you just plot that point. Numbers or points that are in quadrant 1, they're both positive, so you have a positive x, positive y. If you're in quadrant 2, you're a negative x, a positive y. If you're in quadrant 3, you are a negative x value. Notice I would go to the left, then I would come down, so my x and y would be negative. And if you're in quadrant 4, my x's are positive, and then my y's are negative. Okay, so we definitely made our signs here. So be very comfortable with plotting points. But I wanted to get into word problems just for some application real quick, and then we'll stop here. All right, so let's look at this particular graph. Hopefully this is big enough. And one thing that I want to talk about is x is always your independent variable. Okay, so write that down. X is always your independent variable, which means when you're independent, you're writing out the word independent. X is the independent variable. It means that you don't depend on anybody. You're independent, so you live by yourself. You take care of your bills. You do everything you need to do independently from other people. You have no dependency on anybody, right? So things like time. Time is independent, right? Time doesn't depend on anybody. It always keeps moving, correct? So in this case, you'll notice as I show these problems, this says months, okay? That's a measurement of time. So therefore, that is our independent variable. So it always goes on the x-axis. Now your y variable, or the y coordinate, is the dependent. So whatever x does, because that's your input value, will output a y value. Okay, so I just want to kind of do that real quick. So again, x is always your input. Y is always the output. So this guy is the independent, and then y is the dependent variable. Okay, just to kind of throw that out there. So that being said, if we think about it, if they give us some kind of function, and I'm going to write this real quick on a piece of paper. So if I had something like, let's just show you what independent and dependent means, and also let me show you what input output means. So let's say I give you a function, okay, like that. So notice that I will end up putting values of x in, because as you can see, you have the equal sign, and y is over here on the left by himself, isolated. So basically, y will depend on whatever x is. Whatever value I input into here, after I evaluate this side and I do my calculation, it will equal the number over here. So that's why he's dependent and this guy's independent. So let's say I let x equal -2. I could let x be 10. I could let x be 100 or 1,000 or -50. You see, I'm choosing whatever value that I want for x as my input, which that's why he's my independent. I could just choose and figure out who y is, okay? So I'm going to go back to this. I don't know what y is, but when I plug in -2 as a substitution, because x is -2, when I do my math here, it's going to give me my y. So now I have y equals 3 times -2 is -6 plus 7. And rule of integers, subtract, keep the sign of the bigger number, 1. Okay, so here we go. Y equaled what? 1. Why did y equal 1? Because x is -2. And notice we now have a coordinate. You see? -2, comma 1. So just to be clear, this is a function. Functions can be linear, they can be exponential, and all these other kind of functions. But in this case right now, for this math, we're looking at linear functions or equations. So I'm just telling you that if we were to graph this line, I'm just telling you the point -2, comma 1 would be a point that falls on this linear line. And we'll get into that in section 4.1. But I just wanted to be clear of what an input and output is, what does independent and dependent mean, and then let's do this word problem. So here we go. I'm going to zoom back in. So first thing always with graphs in general, if you were taking some kind of problem or test, you want to always first analyze and look at your graph. So I'm noticing number of patients served by month. Okay, great. And then my x-axis is the number of months. There's 12 months in a year. And then I have the number of patients from 0 to 90. So I'm noticing, hey, in the month 1, which is January, I served 30 people. In month 2, I did, see how that's a little bit, pay close attention when they're not perfect. This is not 40. Maybe this is like 38, right? Or 39, okay? Then if I look at the month of September, I'm right on the line. If you look real carefully, this is page 205, and I'm perfectly on that intersection there. So this becomes, I go across and I read 70. And again, this is a 0.9, comma 70. All right. If I go to the month of December, same thing. I'm in the month of December. I go up and I'm in between. Be very careful. Sometimes it's good to use like an edge of paper, but just carefully go across and you notice you're in between 70 and 80. It looks like it's perfectly in the middle. So I'm going to call that about 75 patients, if that makes sense. So here's some questions that they could ask you. Here we go. The question says on A, for which month was the number of patients the greatest? So which patients were the biggest or the most people were served? So we go back to our graph and I look, of course, for the highest point, which is here, and it's month number 10, which is in October. So in October was the greatest month. And sometime when you step back from it, even though you're answering a question, think about the logic behind that. Well, you know that in the fall, winter months, right, people get more ill. So it makes sense that, you know, as I'm moving out of the summer, which usually lasts till about August, you know, transitioning into September, you see that influx or increase in December. Now you're in the winter season, then you have, it dissipates sometime off November and December, okay? All right, let's go to the next one. B, how many patients did the center serve in its very first month? So then that's January. So we go to January, and I talked about that earlier in month number 1. See, it's 30. Just read across right there. Real simple. I'm going to jump around. Let's look at E. Which month corresponds to 40 patients served? So there's the answer there, month 3, but let's look at the graph. So we go to month number 3 and we look carefully and we go across. Yes, 40 patients were served in March. Okay. And let's see, approximately how many patients were served during the 10th month? Well, that's kind of funny because we already looked at the 10th month and it was 80. Okay, I'm not going to show that, but I wanted to see right here, D, between which 2 months did the number of patients remain the same? Which ones did they remain the same? So I'm looking for 2 dots that are basically, look, the same, and that would be September and, who is this? What month is 9, you guys, really? October, August, oh yeah, September and August. Okay, and then yes, month 10 was 80. All right, so I'm going to go ahead and cut the video there. And again, you can just look at some of these just so they make sense. You know, here's another one real quick. These are the number of days. Here's the price per share of maybe some stock or something, right? And then they ask you some questions. Let me just do 1 or 2 of these real quick. So it says, here's one. What was the change? What was the change in price between day 3 and 4? So day 3 and 4 is our X, and then we're looking at the price change. So that means I go to day 3 and I say, hey, on day 3 it was $91.25. On day 4 it was $93. So I would subtract 93 minus the 91.25, and you would get that again, it's a positive change or increase of $1.75. Let's look at one more on part C. I'm not going to move the paper. It says, what was the change in price between 4 and 5? Well, I noticed that on day 4, and then I have day 5. See, there's a decrease. It went down. So you're going to get a negative number. Please do not okay, well, understand. You are going to do 93, right? Minus $90.25. You're going to subtract those, but the answer is going to end up being, even though this is a positive, you're going to say a negative because there was a decrease. So I know mathematically you'll tell yourself, hey, I had a positive 93 minus 90.25, and so you would just say, hey, it's 275. But I'm saying to you that because of the application that it's a price per share, you lost money. So put negative. Okay, or you can always do final minus initial. This is where we are on day 5, and then initially we were here. So you can do 90.75 minus $93, and that will give you the negative 275. So it depends on your understanding. You always do where we are in the current. Here's the past. That will give you the negative answer, or you can see, hey, I decreased. I'm going to make my answer negative. All right, so let me get into starting the next video. All right, have a good night.